Hi, welcome to my video on finding the instantaneous rate of change, and this is word problem number 4. An ice cube with a 4 centimeter edge is melting uniformly such that its side length decreases at a rate of 5 millimeters per minute. What is the instantaneous rate of change of the decrease in the surface area after 3 minutes? So we have a cube, and again, a cube is a rectangular box with all edges the same. So that's the length and the width of the base, bottom, and a height E. So the we're doing the surface area. So the surface area is one face is a square. So a square got an area of this face is E times E is E squared, and there's 6 of them. So it's 6E squared is the surface area of a cube. Now let's look at the length of so the edge of the cube is 4 centimeters. But if you notice, the rate is 5 millimeters per minute, and the edge is in centimeters. So what I'm doing, I'm going to change the 4 centimeters, multiply by 10, and get 40 millimeters. So I won't have any, because if I don't, if I change millimeters to centimeters, then this is decimal 5. So I'd rather deal with whole units. So 4 centimeters is 40 millimeters. So that means that if the rate that the edge is changing is 5 millimeters a minute, then the edge, the length of the edge, which I'm going to call E, is 5 millimeters per minute times T minutes. So the minutes cancel out. So the edge E is 5T millimeters. Okay, so that means that if the edge is 40 millimeters and is decreasing, it's decreasing. So I almost forgot to put the 5 in there, because if I didn't put the minus in there, it would be increasing, but we're decreasing at a negative 5T. So that means really the edge is 40 millimeters starting off and is decreasing 5T millimeters. So that's the edge. So if it's 0, it's 40. If T is 1, it's 35. If T is 2, it's 30, so it's decreasing. So we need 40 minus 5T. So the surface area is 6E squared. So that's 6 bracket 40 minus 5T squared. So we want to find it when the time is 3. So the time is 3 seconds. And we have another time which is close to it as 3.001 seconds. So the surface area, we're going to put a 3 in here. So it's 640 minus 5, T is 3, bracket squared. So we take our time and work this out. We have a 40 minus 15 squared. Keep doing the brackets by PEMDAS. We got 25 squared. So 25 squared times 6 is 3750. And that's in millimeters, so that's square millimeters, surface area. So we have a 3 giving us 3750. Now when we put close to it, which is doing the instantaneous rate of change is at 1.0 at one point at 3 minutes. So we're going to go close to it. So we're going to surface area is 6 and 40 minus 5. So it's 3.001, and we're going to square it. So that's 6, and that's a 40. So that's 15.005 squared. So I can put this in the calculator, but I'm just going to subtract, and I get 24.995 squared. Now sub that in the calculator, punch it in, and when I get 3748.50015. So 3.001 seconds is 3748.515, and that's surface area, so that's square millimeter. So the slope, which is the instantaneous rate of change, and the instantaneous rate of change is the slope of the tangent. It's the slope of the curve at 3 minutes. So the instantaneous rate of change is y2 minus y1, x2 minus x1. So it's 3748 decimal minus 3750, and x2 minus x1, or this could be surface area 2 minus surface area 1, and time 2 minus time 1. And when you if you're going to plug this in a calculator, put a bracket, type this in, bracket, division sign, bracket, type that in, bracket, and when you hit the equal sign, you get a negative 1499.85, and that's millimeters. That's surface area square millimeters per minute, and to round that off is 1500. So it's 1500 square millimeters per minute. That's the rate of change of the surface area in terms of time. Now, what about if I had changed, left this at 0.5? So this would have been decimal 5 here, working it through. If I did, here's what I would have got. So if you take 1500 millimeters squared, and here's what I'm going to do, 1 centimeter times 1 centimeter is 10 millimeters times 10 millimeters. So 1 square centimeter is the same as 100 square millimeters. So if that be the case, I can go up here and convert square centimeters to square millimeters. So I have millimeters on the top, so I'll put millimeters on the bottom to cancel them out. And I'll put square centimeters in the numerator. So I got square centimeters and millimeters. So 1 square centimeter is 100 square millimeters. So notice that the square millimeters will cancel out, and I will get 100 cancels out, give you 15, so that's a negative 15 square centimeters in 1 minute. So I just did that little conversion for you. But again, if I had to put a 0.5 here and 0.5 centimeters, then I would have come up with this answer in square centimeter. But I just showed you the conversion, that you could do it either way. So that brings us to the end of this video. Again, this one's a little bit different because you're starting off with 4 centimeters and it's decreasing. So you had to come up with this 40 minus 5t as the length in terms of time. And if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.